Cool. So I don't think anybody's actually watching right now, but I'm just gonna go ahead and start doing some stuff. So I have a nice bottle of Cupcake Vineyards Red Velvet wine that I'm gonna be sipping while I do this. And yeah, so last time we were making a Callgraph plugin, and I did it a certain way, and after that stream, even though nobody could really hear anything that I was saying, I decided that it was probably a bad way of doing it. So I was looping over all of the medium level IL instructions and looking for the calls or the tail calls, and that can find some stuff, but I have a specific instance here. So I have this bomb. I don't even know where I got this from. It's some crack me type thing. It wants you to like type in some like words or something, and yeah, doesn't really matter. But here's the thing. So if we go ahead and do the Callgraph, this is all you get. And this is exactly why I think that the method I was using earlier was a terrible method. And so if we go back and look at start, you can see that it does call libc start main, but that's an external symbol, so it doesn't really get us anything because main is actually passed in as a parameter. And so if we look at the medium level IL, this is the only call that we see, and that just tail calls into the actual imported symbol. And you can see that your functions are actually these right here. I'm just pressing O right now to make those pointers. So I want to redo this a little bit tonight, and the thing that I'm going to do is actually use the code refs, which is really the way I should have done it before. Also, we can do data refs as well, which I think, well, data refs might not be a good idea. We'll get to those later. So let's see what we need to do. So the first thing that we probably need to do is just well, we can get rid of all of this stuff because we're not going to use any of it. Well, let's leave that. So let's get the functions first. The first thing that we probably want to do is actually just do function in view.functions, because we know that all of our calls are going to be at a function call like this, or it's going to be a function in the binary. This won't necessarily work for things that haven't been discovered, but if you're running stuff, if you're doing like a linear analysis, linear sweep, you'll get most everything, and you can always create more functions and stuff as well, and then regenerate your call graph. That's actually something that we can get into later, something I haven't actually played around with, so we can learn that together. So we've got our functions, and we want to get our code refs. So code refs is going to be view.getCodeRefs, and we want function.start. Actually, let's do for ref in, because we don't need to get a list of them, I don't think. So then, let's see, how did we do this before? We had our calls. Yeah. let's do that again. And we can do, I'm still sitting here trying to remember how I did everything before. So we have our dictionary of calls, and the keys to those are the functions, and the value is going to be a list of all of the things that call that function. And so I think that's actually going to be the opposite of what we had last time. Yes, so last time we had caller be the key and callee was the value, but this time we're actually going to do it the other direction. And so calls, callee, wait, no, let's see, callee is going to be ref.address. No, that's caller. Man, I'm getting myself confused here. So the ref is going to be, let's see, will it show me what that is? No. All right, well, what we're gonna do is look at the API real quick so I can talk about this. Let's see, we want Callgraph. Get code refs. So get code refs is going to give us a reference source, and reference source has a function and an address. So that's actually kind of nice. We don't actually need the address itself. We actually want the function. So we can actually just call that instead, I think. Yeah, so new function reference. Yeah, that's pretty cool. I had forgotten that I usually just get the address out, and sometimes the arch, I think. But now we can go caller equals ref.function. And if calls, let's see, let's do caller list equals calls.get callee, and if that doesn't exist, then we'll just create a list, and then we can just do callee equals caller list plus caller. That's probably cool. So now we've got that. We're gonna have to redo all this down here as well. Let's see. So where are we going from there? Actually, let's just see what happens. Go ahead and comment out all the other stuff that I had down here. Just save that and go ahead and quit. For some reason, the reload thing hasn't been working for me for plugins, so I have to restart, which kind of sucks. But we'll go ahead and load this back up and generate Callgraph. Oh, I've got more errors. This is a big part of my streams, is looking at the Python errors that I have. Oh, that's stupid of me. callee should just be function. That should just be function. All right. Well, looks like it worked that time, but we didn't output anything because I'm silly and didn't actually put the print statement like I wanted to. So let's just go ahead and put it here. Do that. And actually, let's try this. And then instead of actually executing this down here, let's just do a collect calls. And pass in binary view. Well, that didn't log anything either. Huh. Well, it did the log info right there. All right, let's try callgraph equals, oh wait, no. Import lib, because I'm using Python 3 instead of the default Python that comes in the with Binary Ninja. That's a pretty simple thing. I guess we can do a sidetrack real quick. Yeah, if you go up to edit and go to advanced settings, this is something that they added pretty recently, and I think this is in stable as well. I'm usually on the dev channel though. You have Python interpreter, and they actually auto identify a lot of Python locations in the dev channel currently. I don't think that one's made it to stable yet. But you can just pick whatever Python you want that you already have installed, and I currently am using Python 3.7. So yeah, so anyways, so we have to use import lib to reload. All right, now let's see what happens. Yay, there we go. That worked. All right, so we have all of these functions, and these are the things that are calling them. So let's double check one of those. So that's going to call 80486E0. 804. Oh, that might be. Does that start? Yeah. Okay. And let's see. This one is not it. I think this is, yeah. So 80486E0. That's called in two places. Oh, maybe I should make this a set. Yes, so that's why you get that. So what's going on here is you get a code ref for the push, but you also get a code ref for the call here, because in the medium level IL, these are parameters at that address. So that's why you end up getting a code ref there. See how it's, yeah. So that's why. So let's make that a set. I wonder, is there a set way that what happens if you do an add to a set? Where's my term? Sorry, just having technical difficulties with getting a terminal to come up. Let's see. Oh, this is 2.5. So let's make a set. Let's say a equals s dot add 2. A is none. Okay. Is there a update? Set so we can just do that. No, that still doesn't return it. Let's just do an add here. Wait, no. Let's do our nice import lib again. Oops, untype object. That doesn't really make any sense. You should be returning a set. Man. All right, let's try this. Now we've got a set, dictionary, and a equals b dot get to set. Okay, what the hell? Okay, that is the exact same thing and didn't work. Oh, that's why. It's because it's the second one. Okay, can't do that. Look at me trying to be fancy and it doesn't work. Oops. There we go. All right, let's try that. Okay, now let's see. All right, yes, so now we get a set where it's only the things that are actually calling the function. Though, kind of looks like most of these are only ever called by one function at a time. Oh, no, here's one that's called by two functions. Cool. All right. So now we can go back to what we were doing earlier. I see a couple of you in chat, so that's kind of, I know you're not talking, but I know that you're watching. So, hi. All right, so now that we've got that, we can delete all of this here because we've got all of our callers and our callees. So, let's see. Let's just label this call. So that way I don't get myself super confused again. So I think we also are going to have a little bit of an issue here at some point if I have multiple entries into this call graph, but we'll deal with that later. So we've got our flow graph, got our function nodes that we haven't created yet. We will start the queue with the entry point again, and our empty set, that is which nodes that we've seen, so we can just ignore them. So we're gonna go ahead and create a new node, and this is gonna be the callee. And there we go. So we get the callee. If it's been seen, we just skip it. Otherwise, we add it to the scene. Now we're going to come in here and create our node. We'll save it into our function nodes. And we'll also set the name. And we'll add that node to the call graph. Otherwise, we'll just get it. All right. Got to make sure all my, let me see if I can just rename it. Hopefully that doesn't mess anything up. Oh, yeah, that's cool. All right. So anyways, I think that's all of them. So callee node is our, oh, thank you. So callee node is our flow graph node. We add it there. If it doesn't exist already, we set the name, we append it to our call graph. Otherwise, we just get it. All right, and so now we're going to, this is where it changes. We're going to create nodes for the callers and add edges. So callers equals calls dot get callee. Caller in callers. Caller not in function nodes. We can probably actually just make this a function. Why don't we do that? Let's come up here, say get or set call node. And what all do we need for that? We need the call graph, function nodes, and callee. Let's say node. Oh, no, let's say function. Let's see if I can rename it this time. Nope. Hates me for some reason. I don't know. Oops. Node. And then let's just return the node. Callgraph function nodes function. So I should just be able to replace this with callee node equals get or set call node call graph function nodes and callee. And then let's do it here too. Call our node equals get or set call node. And we'll do the Callgraph function nodes and caller. Now that we've got that, we can actually add the edge. So it's just going to be, oh right, I had the weird thing last time with this. Where I had to do this thing here, but I don't know if I have to actually do that this time. Let's do it anyways. So because there's no hash, I think, on the, or maybe it's compare. Either way, there's no way to like distinguish if two objects that are wrapping the edges object, the core edge object, if they're the same edge object in the core currently, because they don't have those comparison functions. So you have to do this annoying thing of checking the actual pointer to the core object itself. So I do this little thing where I'm just going to type it again. Create a little list comprehension of all the edges. And put that there. Node.add outgoing edge callee node. Oh, and yes, we need branch type dot unconditional branch. And now we should just be able to delete all of this right here. And let's go ahead and add, actually, can you do that? Whoops, hit the wrong thing. Let's see. What happens if we make a list and add something and then do a set yeah, I can't concatenate it, so we'd have to turn this into a list. Although maybe I could actually make that set. Doesn't actually have to be. Can you do that? No. Just do it like that. And then we can just do update. And that should work. So let's do a println of the nodes to see if it actually works. Nope, because I did something wrong. All right. Visual Studio, tell me what I did wrong. It's because this, oops. There we go. That should fix that. And I missed one. Oh, it's callers. Isn't it fun watching somebody program? It's like you're looking over my shoulder from thousands of miles away. 1. Okay. That is definitely not true. Okay, that's undefined, which means that if it didn't get to that, what did I do wrong? Oh, right. This should be callee, I believe. Oh, callee node dot handle dot contents. All right, now let's go ahead and print scene out. See how many of these we actually see. We only see one thing, so we have done something horribly, horribly wrong. All right. So come here, getter set the callee node. Let's see what happens if we print that out. Okay, what in the world is going on here? So it's definitely getting into here. There's this I've made a really stupid mistake, I think, and I have no idea what I've actually done. So I think this means that I need some more wine. So it's not seeing it, but then it adds it to the call. Let's do a this is why I use Python 7, 3.7. Love format strings like that. Okay. So we got to there. Okay, we did get to here. I forgot that graph node is the standard repr function for flow graph nodes, which gives you absolutely nothing. So let's see what we can figure out from here. So we got to there. And we saw that. Saw that. So then that means that this must be the issue. Oh, that's right. We're backwards. So we're seeing the first function, the entry point. Actually, why am I even doing this? Should just be, oh, this creates a function, I think. Just do that, and I don't even need to do this. I don't think I even need the scene either. Yeah, oops. Go ahead and take that out. Yeah, it's a remnant from yesterday, or a few days ago, where I was doing it the opposite direction, and it made sense to actually start with the entry point, because the entry point was a caller, not a callee. But this time, since we're backwards, the callees are the ones that we're adding to the queue. Oh, BB. Silly mistakes. Bound. $60. That's a lot better. Let's see what it looks like. Ooh. That didn't come out very good. What did we do wrong? Print out all our nodes. Two nodes double lines. Let's see what we get. Oh. It's because I'm on the Callgraph. Callgraphs don't have binary views, so the BV global was giving me nothing. So let's go ahead and do that again. All right, so got a bunch of things here. This looks about right. Now, let's add seems like I'm just not getting any outgoing edges added. And so they're all just kind of stuck on the same one. Ugh. Keep doing that. Yeah. So yeah, so that's the issue I'm having. So what we need to do is actually add a entry point. So what we need to do is actually add an entry point, because the problem is that you can't add multiple root nodes to a flow graph currently. So we need to do a root node equals flow graph node, call graph, and we'll do a root node dot lines equals, let's just do empty. That'll probably work. And then it'll just give us a little tiny box up at the top. So now, how do we determine which things need to actually be connected to that? Well, we have a callee, callers, if not callers, Then let's add node dot add outgoing edge calling node. Let's see what happens with that. I remembered to close it that time. Target, of course. Always forget. Ooh, let's do a false branch. That'll give us some nice color instead of everything being blue, as you'll see. Nope, okay, that didn't save us. Here is our, did not add it. Oh, I didn't add it. That was the other part that I forgot to do here. Callgraph.append root node. So it added this, so it added a bunch of outgoing edges to this node. This is kind of an annoying thing. You would think that if you created a flow graph node and pass in Callgraph, that appending it would happen automatically, but it doesn't. So you have to remember that. That's a common gotcha with the flow graph stuff. So if we do this time, haha, there we go. So now we get a nice, I should just rename that something. This looks pretty good. Oh, we even get a little loop here. See how that one's a bolded function, bolded line? Same with that. You see there's a little loop going on there. That is nice. You see start, it does in fact call Finny. And we've got libc start main and init and then main here. Now the one thing is that I'm doing code refs, and that means that if a function pointer is referenced in a function, it's going to be considered a call. So what you would want to do is probably say if the this is where the medium level IL would come in, or even the low level IL. You would say if the code ref is a call, then add it to the thing. Oh, I had a bunch of. Oh, that's probably from before. All right, let's get rid of our output stuff. Let's change this to the just say top, or no, just name it root. Get rid of that. Take this print out. Excuse me. Didn't need on there. Hope this isn't boring you. It's not boring me either. I'm enjoying this, but I know there's no music or anything like that, which it's not as fancy as other streams, I guess. But you know, I don't really know what I'm doing, honestly, when it comes to streaming stuff. I just wanted to fuck around with Pioneer Ninja on stream. So what was I gonna do here? Got rid of all that print stuff. Layout and weight. Oh, right. I don't know why I forgot about that. Okay, so we're up here. So I don't want to add the collar yet. This is where the let's just do go get low level IL at draft address dot operation equals low level IL operation. Is there a tail call? Yeah, we'll have to do that too then, I think. Oh, extra. Actually, let's do calls.function. Just get rid of this completely. Yeah, that looks a little nicer, I think. Let's see if that works. It might do something horrible. I don't know. Oh. Let's get low level IL at. So what this is going to do is get us the IL instruction. And that will then have an operation on it, which will tell us whether or not it's a call or a tail call. If it's not one of these, then that means that it's something else like a push or like a move or something like that. That's actually just referencing the function pointer, not actually calling it or passing it into something else that would call it, which you might, it's still a janky heuristic. You might want to do something where it's actually like, is this call something that's known to actually call one of those things? Or we could do something like, let me see. Let's see what this is. It's an LIL call, and the dest is const pointer. So we get that, and then we can do a bv.get symbol. I think it's at. Yes. So you could do something like, if this symbol is an imported symbol, we're just adding more onto our heuristic here. Let's do it up here. desktop operation. I can't win with the really long lines here, but I guess it's still under 100. That's not too bad. So we add, we make sure that it's not none, and then in case it's like a an unnamed function, and yeah, I'll just have to call it again. Oh well, I don't really like that, but I could rechange the if statement or something to clean it up, but I don't really feel like doing it. I think we want an imported function. Yeah. Ugh, over 100. Ugh, it's so ugly. Oh. Invalid syntax. Did I mess up? Okay, cool. All right, let's see what happens. It's probably still going to give us the exact same thing because those other functions are called. The interesting thing, though, is that what we really should do is add the function that is actually being called there as the caller. We'll do that in a second. Let's see if this actually worked first. I mean, it should still look exactly the same, but you know. Sorry, I've gotten distracted. I'm looking to see if things like this are being called from other places. Doesn't look like it. Wait, flush. No, nope. All right, cool. So that looks like a bunch of stuff got moved out. I can't, of course, mess with those. Oh, it's because okay, so this was the previous one. Yeah, something's wrong. So maybe that wasn't a good idea. So these are calls. Huh. All right, let's see. sure these are current LIL 39 operation. It is an LLIL call. Const pointer. Oh. That's why. Let's just take this off. I think that was probably the problem because it was only doing then the ones that were tail calls and things, I think, into exported symbols. See if that's a little better. Yeah, there we go. Though I think that's technically exactly the same. But you can't really tell, but because we're deduping these, but if we weren't deduping them, I think this would only have one line now. Now, the real thing is that this, we would probably want this to come under here. But I think it's okay to know that a particular function pointer is directly referenced in a different function. So this is kind of cool. Got our nice little function chart. Now, the one downside is that I'm pretty sure that there's still a bug right here. So if I click on this token here, yeah, it crashes. So we'll get a thing in a minute for that. Good. Open that back up. So see. So we get our generate call graph. Now, the one thing is that we don't get the tokens like we did before. So that's the next part that we want to do. We want to turn these into actual instruction text tokens that we do. Let's see. So we add the line up here. All right. So when we do the lines, we don't want to add the name. We want to add a disassembly line. Assembly text line? Yeah. So we want to do an instruction text token. Make this all nice and pretty. All right, so the token type is going to be an instruction text token type. For now, we will just do a, I think it's a code symbol type that we want. There's a pointer. I think there's a possible address token, but I think that would just give us the number. Yeah, let's do that. So text is then going to be function.name, value is going to equal function dot start. Let's make that nice and pretty as well. So the nice thing about instruction text tokens is that the string that you display doesn't actually have to equal the value of that token. And so you can provide a numerical value for the token while still presenting a symbol name. And I think that this will give us what we want, where it will link it to us, but we can't really test it because of that bug. The other thing that we can do, well, let's do this part first, and then we'll get to that. So I'll go ahead and quit and restart it. So come in here, generate Callgraph. Oh, we got green now. That's not what I wanted. Can I change the type? No, I can't click on those things. Ah. What? Maybe it is the code one. So let's see. Oh, there's our notification of the. Let's actually bring that up. So yeah, you can see that the crash happens when it's getting a token for the mouse event. So I'm guessing there's like a use after free here or something like that. Like, I know that there were some issues with freeing instruction text tokens in the wrong place. So that could potentially be the issue. Let's try address display token. No, that didn't do it either. And I accidentally clicked it, so I crashed it again. Whoops. All right, so here's how we're going to do this then. So we want to do bv.disassembly at here. Nope. That's not it. Let's see what it is. Get disassembly. Oh, that might give me just the string. Let's find out. Yeah, it's the string. That's not what I want. So let's do bv.arch.disassemble or get instruction text. This will give me the instruction text tokens for sure. And then, but the problem is I have to pass in a bunch of data. So let's just pass in 10 bytes. That's enough. Oops. Got it backwards. There we go. So get that. t0 is going to be that, and then we get that, and it should be a type instructions text. Yes. So then if we look at the type on that, it is a possible address token. The value is that, and text is that. Okay, so we have to, does it have anything else on it? Oh, there's an upper hand. No, I don't think that actually does anything. Type names. Nope. Nope. Okay. So what's context? No token context. Okay, well that doesn't help us. All right, cool. So we want to do a possible address token. Need to add. That's why it's not working. So it needs a binary view context to know what the symbols are. And as we previously saw from the fact that I couldn't type BV, I'll go ahead and show that. So if I do a BV here, it's none. BV none. See. So what we need to do is actually set Callgraph to have let's see, I don't think it has a view on it. Yeah, but it does have a function. So what we're going to do here is we're going to do, we just need to add a function to it. Actually, you know what? Let's just do function 0. No, we don't have to actually get a function. So let's see, now we come up here, we put a possible address token. Do this as a X value. See what happens if we do that. That's not us. Nope, that didn't work. Ooh. How can I click on these? So it's a specific type of text token. Interesting. Also, why is there a bunch of space there? Call target 0 does not appear to be code. I want to display this token. Oh, Huh. Why is it doing that? So that's 60. Not. Is that the. Yes, of course, that's the function at the beginning. So let's do the entry point. Okay, this one should be able to give us the thing that we want. So, all right, what we will do, of course, that's the one that I get. View.get function at view.entry point. All right. Still didn't get them, but I can still touch these without. Although they still won't. Aha, but I can click them like that. Why aren't there symbols showing up? All right. Ooh, what have I done? Okay. So let's do current function create graph. I think that's what it is. Yes. So we've got a graph. G.nodes. Oh. G.layout and weight. G.nodes. There we go. All right, so I want G.nodes 0 dot lines. Let's just look at the first one because that apparently will get us what we want. The tokens? Yes. Code symbol token. Should have known. And let's see. It's probably that text and that value. So I was correct here to begin with. I can take that value off. It's in the right position. All right. Let's see what happens now. Haha. Now, here's the question. Can I click these? Do I have any? Doesn't look like I have any of the import ones, which is fine. All right. Oh, I can. So it's just regular tokens. Cool. Well, I'm glad that I was able to do this. All right. Now I want to find out about this one. Is that an imported token or something? I believe it is. Import token. Yeah. All right. So what we want to do here is do that and say if like a is import or, oh no, I want current function. Is call construction, no. Tokens, symbol. There we go. Yeah, that's what I want. So if function.symbol type is symbol type dot imported function type, token type equals instruction token text dot imported token instruction text token type dot import token else token type equals code symbol token. Oh wow, that's interesting. There we go. I'm still learning how to use the command palette. Hey, look at that. So now we have all of these. Yeah. Interesting though. This does not have any calls on it. It should have a call right here. I wonder why that is. Huh. So that's a call there. Let's remove that one little thing. Let's see what happens. Is that what the problem is? It's the oh, call stack adjusted. Call stack adjust. I always forget about that one. All right, let's try it again. This wine is pretty good. All right, let's see. Yeah, there we go. So now we have that there. You can see our calls to things. You can see the secret phase that this thing has. Ooh, nope, that's detours, and that's ctours. Okay. Huh, that's really weird that the bug is just with regular instruction text tokens, like a specific type. It's pretty cool, huh? So you can see that one doesn't really do anything, so it doesn't get called by anybody, it seems like. Don't really know what the point of it is. Cool. So yeah, you can see there's loops. I really like that. I love how they added that in. What? Let's do something fun. Let's take that and I don't like the blue with the blue symbols. So we can use a nice green. Yeah, adds a little bit of color to it. And there's our thing. Wonder why that one's. Wonder how open client FD gets called. See, pass to something. Yeah, I don't see it. So yeah, that's that. I expected that to take a little bit longer, but yeah. So now we have a nice working Callgraph, basic Callgraph plugin. That's really all it took. I didn't really talk about this tonight, but I put it in a background task thread because that allows us to run it without being on the main thread. So if you happen to run it while it's doing some sort of analysis, it won't be able to do anything while the analysis is running because the analysis is on the main thread. So I actually ended up hanging it because I think it kind of got into a infinite loop kind of circular dependency thing there, and so I switched it to using a background task, and now yeah, I see that chat's been pretty quiet, so I guess nobody has any questions, although I will try to come up with something to do next time that's a little bit more involved. I just wanted to kind of do something simple tonight, and I don't know, maybe I'll do some reversing of something the next time. But yeah, cool. Hope you enjoyed it, and thanks for watching.